So this problem is going to require a little bit of dimensional analysis. They were nice enough to provide us with the relationship between decagrams and grams, and then the relationship between milligrams and grams. If you've done a little bit of chemistry, you probably already knew this relationship, but they give it to us here, and what they go on to say is the hospital stores one type of medication in 2 decagram containers. Based on the information given, how many 1 milligram doses are there in one of these 2 decagram containers? So it's essentially trying to figure out how many milligrams there are in 2 decagrams. So if we go through a little bit of dimensional analysis, I'm taking the 2 decagram volume of the container, I'm multiplying that by a fraction that's going to allow me to have decagrams show up in the denominator so that I can cancel the decagrams from the numerator with the decagrams from the denominator. And my answer is going to be measured in grams initially, right? So these would cancel, and then my units would currently be grams. But I've got one more step here to carry out, and that's to have my end result be measured in milligrams rather than grams. So if I multiply by another fraction that consists of the relationship between milligrams, so we've got 1,000 milligrams per 1 gram, I can cancel the units of grams, and if I do 2 times 10 times 1,000, my end result is going to have units of milligrams, and that will be how many 1 milligram doses there are in that 2 decagram container. And there is a calculator in play here, so you don't have to necessarily do this by hand, but in this case it's not that bad. 2 times 1 times 1, if I ignore the zeros, gives me a 2, and then if I tack on the zeros to my answer, 0, 0, 0, 0, I end up with 20,000.